All right. Let's take a look at these and see if we can figure out which ones of these are linear, which one of these are exponential, how we can tell. What are we looking at? So our linear functions, if we were to graph them, make a line. So it would be something that would give us a straight line like this. Exponential functions can either be growth, where they get bigger like this, or they can be decay, where they get smaller like this. So think about if something's going to get real big real fast, or if it's going to get real small. Or is it changing by the same amount? So let's take a look at these. Lock it in, guys. We got another chapter to go. If we have, locking in, guys. If we have a savings account, it doesn't earn any interest, but it gets $723 per month. Every month it gets $723. What do we think that might be? Linear. It's going up by the same amount each month. The same chunk is added each time. So this one's going to be linear. Our rate of change is constant. It doesn't change. It is a constant increase. I know. What about B? What do we think about B? Exponential. Is it going to grow, or is it getting smaller and doing decay? Ooh, hope so I don't write these two words at the exact same time. Exponential. There we go. I think those are the right letters. And how do we know it's decay? It's getting smaller. It's getting less. It is depreciating. So that's how we know this is going to be decay. It's going to get smaller. What about C? What do we think if every week 9/10 of a radioactive substance remains? I heard two different ones there. What do you think? Think about if I have 100 and I have 9/10 left. On the second week I have 90, right? So if this was 100, and then in the next week I'd have 90. Then I'm going to lose going to keep 9/10 of that. So the next week I'd have 81. Yeah, I was going to say, since it's what we are changing by changes, since we're only comparing exponential versus linear at this point, what we're changing by changes. It's percent per day, or it's a fraction each day or each week. That's how we know it's exponential. So this is exponential. And since this one is also getting smaller, this one is also going to be decay. It's getting smaller very slowly. But it is getting smaller. What about for part D? A liter of water evaporates from a swimming pool each day. Linear. 1 liter is changing. Whether that pool is full to the top or it is at the very last liter it's got. It's got 1 liter evaporating. So this one's linear. And our last one here, every 124 minutes, half of a medicine dosage remains. Since it's cutting by half each time, the amount it's changing by changes each time. So this is also exponential decay. I'm slightly annoyed they don't actually have a growth on this page, but it's good for us to notice. I know. They don't have a growth on this page, but there's only so much I get to change now. So we're going to look at the next page as well, because we're just starting out by looking at what these relationships are, how we notice it. When we have the percent per is a good indication that that's going to be exponential. If we are taking fractions, of something, that's a good chance it's going to be exponential. So what we're going to look at next is we're going to look at some equations on the next page. We're going to figure out some pieces about it. We're going to figure out what rate was given. We're going to figure out how many they started with, and we're going to make kind of a sketch. So we're going to start by looking at what these look like. So this is on the very next page. I have two next to each other. And I have up here that equation we kind of wrote yesterday. We were talking about the amount we have, P, what we start with, our 1 plus or minus R, and our T up at the top. So P is going to be our principal. It's our initial amount. It's our starting place. R is our rate as a decimal, and T is our time. So what we're going to look at on these is we're going to try and figure out what P is. We're going to look at that piece that has the exponent, which has a name. I'm going to tell us in just a second. And we're going to try and figure out what that R is. So first thing I want us to look at is I want us to see if we can figure out what our principal amount is on this guy. What is our starting place for part A? 8. It's this guy right here. That means day 0, when they started, they had 8, whatever thing this is. So if we wanted to try and graph this, we could do that. We just know we're going to start at, when we have a 0 here, when x is 0, we're at 8. It's our starting place. We want to try and find our rate, which is inside the bit that has the parentheses. Oh, sorry, let me write down the part about P. So our principal or starting place is 8. When we're looking to figure out what our rate is, we're actually going to start by looking at a whole chunk that has a name here. And what that piece is called the growth factor. And this whole chunk right here, the piece that has the exponent, is called our growth factor. It's what we multiply by to get it to change. So sometimes we'll have problems where something will like double. That's going to have a growth factor of 2. Or if it triples, it has a growth factor of 3. So our growth factor is the chunk that gets the exponent on it. In this case, it's 1.23. For me to get to my next place, I would take my 8 and multiply it by 1.23. It's going to make it get bigger. If it's over 1, it grows. If it's less than 1, it decays. So our next piece up here would go up just a little bit. We can tell because it's growing. The other piece we want to find is we want to find our growth rate. Our growth rate is very much related to the growth factor, but it's specifically what would need to be added to 1 to get that growth factor, 0.23. So our growth rate is 0.23, or what is that as a percent? Or 23%. Most often, we are going to write growth rate as a percent, but we write growth factor as a decimal. We will need to have to identify both of those pieces. So since we have a growth factor that's positive, we know our graph is going to grow. If this is bigger than 1, it's going to grow, and our graph is going to look kind of like this. It's going to keep growing. If we have a growth factor of less than 1, where we have like 0.9, 0.4, 0.2, it's going to get smaller. So we're going to start out by just looking at those bits of it here. And I want to see what we can do with the next one. See if we can figure out our starting amount. See if we can figure out our growth factor. Those two pieces are the easiest ones to get. So this one was part A. This one is part B. what is our principal? 3.1. That's our starting place. That is our y-intercept. It's where we begin, however you want to think about it. What is our growth factor? 0.78. I'm just going to call this GF. Growth factor is our 0.78. So is this going to grow or is this going to decay? It's going to decay. It's getting smaller. If I take 3.1, our starting place, 3.1, and we times it by 0.78, it's going to get smaller. It's going to go down. So when we're looking at these little sketches, we're not looking for perfection. We're just kind of getting the vibe. We're getting our starting place, and then is our next dot going to go up or is it going to go down? And in this case, it's going to go down. So it's going to look kind of like that. The next piece we need, our last piece, is we're going to try and figure out what our rate was. So we want to know what the growth rate was. So we want to know what was added or subtracted to 1 to get this 0.78. So if it's not something we can spot, like on this one, it's pretty easy to spot that this was 1 plus 2.3. You can always set it up as an equation. Since we know it's smaller than 1, very clearly, we know this was 1 minus something equals that 0.78. And we can solve that. We can figure out what R is. If we subtract 1 from both sides and then divide both sides by -1, we'll figure out what R is. What is this R going to be? It would be 0.22. Or it would be a decay of 22%. So our growth factor is the chunk we have here. Our growth rate is what's being added or subtracted to the 1. The next one's a little bit weird, but we're going to look at it. Because it's got some weird things happening. So C is a little bit weird. Let's take a look at C. Because what's going on with C? I was going to say, we don't have any decimals here. We're like missing pieces is what it looks like, right? We have an extra fraction in our exponent, and we don't have like the parentheses going on here. So is the 3 our principal, or is the 3 the growth factor? What do we think? Because our principal is multiplied out in front, and our growth factor is the dude with the exponent on it. So does the 3 have the exponent on it? Yeah. So what's our principal then? What's multiplied out in front? What number is multiplied in front over here? What can I multiply by anything and have it not change something? 1. Our principal is 1. This is not written there. If I wrote this like that, 1 times 3 to the t over 2, that's totally fine. We can do that. And if it helps you to do so that it matches up with the things we're doing, that's totally fine. 3 to the t over 2. The weirdest thing with this guy is this t over 2 bit. Because normally what we had is over here we just have t as time. So it would be like for 1 year or 2 years. This is, we're taking our years and doing a weird with them. Like we're cutting them in half. So one way to think about this is to think about when our powers would equal 1. So when we would have an exponent of 1. But I think, honestly, the easier way to think about our growth factor here is to say I genuinely hate having fractions in my exponent. So I'm going to rewrite this as 3, and I'm going to split up my t over 2 to be 1/2 times t. T over 2 is the exact same thing as 1/2 times t. And then we can use an old school algebra 1 rule to write this as 3 to the 1/2 to the t. And I can get that t all by itself. For the power of 1/2 doodad, it's icky and gross, but we can type it in the calculator. The yellow calculators will let us put a fraction up in the exponent. Because what this is really doing is it's making our time change. It's playing with the time units. Because what this really is it's going to be the square root of 3. If you type that in the calculator, it gives you the square root of 3. Or it might give you the decimal. I don't have it written down. But what our equation actually is y equals the square root of 3 to the t. They just wrote it weird. So when we have these kind of fractions up here, I highly recommend we scooch them in like this and type this sucker in the calculator. Because otherwise they're trying to tell us that this is going to triple every 2 years. Or it scooches up by square root of 3 each time. Our growth factor here, we need to get down to this bit to have it, is the square root of 3. It's kind of gross. This is kind of icky. When they have fractions in the exponent, that's what it's doing. It's playing with square roots in here. It's not going to be a super common thing that we have, but it can happen. For our growth rate, we would need to get our square root of 3 as a decimal. Which I don't have my calculator over here. Because our growth factor as a decimal, we need to know what square root of 3 is. I'm going to grab the calculator so we can do it up on the screen, and I can show you how we can also do the fractiony bit. There we go. So if we have that 3 to the power of 1/2, the calculator is going to spit out a decimal. It should. Okay, I guess it's not going to give us the square root. But that's also fine. We can write our growth factor as this 1.73 blah, 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 blah. When in doubt, give yourself at least 2 decimal places. And now we can see that this is going to be growth. And this is growth by, sounds like my mom calling. Our rate is going to be that 0.73 where we've added that to our 1, or 73%. So it's growing by 73%. So this bit right here, we can type all in the calculator. You don't have to have it as the square root. I just wanted us to kind of see that bit. It's weird. We're going to look more at what happens with those kind of fractions in the power as we get later in the chapter. It's not going to be something we see super duper frequently, but it's just something I wanted to touch on. For part D, I want you guys to try this one. Is this growth or decay? What is our growth factor? What is our growth rate? And can we get a sketch? C is definitely the ugliest one. All right. What do we think? What's our principal? Okay. What's our principal on this one? 1. We don't have anything multiplied out in front, so our principal is 1. That is our starting amount. That's where we begin over here. Just burying ourselves. So we have a starting place at 1. What is our growth factor? Three over 2. We could also write that as a decimal. What is 3 over 2 as a decimal? 1.5. So what is our rate? 0.5. Or as a percent? 50%. And was this one growing or is it decaying? Growing. It is going up. We can see that here. So if I start at 1 and it's got a growth factor of 1.5, if I went over 1 unit of t, this would be at 1.5. If I kept going, it would keep going up like this. So this would look kind of like this. Okay, so these kinds of looking at the growth factor versus the growth rate are going to come up frequently. We will use growth factor in a couple of formulas way later on in this chapter. In fact, the calculations for how you figure out like retirement savings, that kind of stuff, uses growth factor in its calculation. So we will be finding growth factor a bunch of times. Rate is more common when we're looking at things like banking accounts and savings account. You hear it in like the commercials. Come to Ally Bank. We have a 3.9 APR. That kind of stuff. Those would be our percentile rates. So rates we are going to get from usually advertising. Growth factors would be things like they double or they triple, things like that. But it's important for us to be able to notice both of those pieces in all those things. Okay? So I encourage you to look at number 4. It kind of, part E. It combines all those pieces together. We've got a starting amount. We've got our growth factor. We can find a growth rate. We have a kind of funky thing happening with time, etc. Tomorrow we're going to look at the next page and go from there. So the very first homework for this chapter is based off of what we did yesterday and today. So see what we can come up with for that, if you have not done so already. Most of us have not. So work through some stuff. You guys have about 10 minutes now. There is kind of a shocking amount of missing homework in this class. Just saying. Pretty much everybody has something they can do. So try a thing, please, because this grade does count in your GPA. So, 1984, not in a very long time. It was assigned reading when I was in high school.